Okay, here's another little demo that we do, and this one here is using what I call a refraction tank. And so we've got this in the lab here, but I just want to test your brain cells. Remember, we've been talking about that idea of constantly actively revising and retrieving information from your brain that really solidifies and puts the knowledge into your head. Okay, so let's just test you out. What did we call that ray that was going into a boundary? So here we have the ray. It's going into the boundary. Remember, the boundary was the place where one medium meets another medium. Okay, in senior physics we learned that it's called the interface, but we don't have to worry about that in junior science unless you want to extend your brain cells. But what is that line? What's that called? Well, remember, that's called the incident ray. Okay, so let's write that in there, incident ray. And then of course that incident ray, what does it speed up or does it slow down? It slows down. Remember that mud analogy with the car? As the car comes in at an angle, the wheel slows down. Well, the same happens with light. And so our ray of light here bends and goes in a slightly different direction. And we have this angle here, which we called the angle of refraction. So let's put that in there. So angle of refraction. Right, once again, filling in a blank. You've probably done it multiple times with your little whiteboard that you've got in your study, but constantly challenge your brain cells. And what do we call this ray that comes out this direction here? We call that the refracted ray. So let's write that in. Okay, we know that the normal is at 90 degrees, and we've only got to label one more thing here, and that is this angle here, and that of course is the angle of incidence. Running out of room there. So the angle of incidence does not equal the angle of refraction, right? So let's check this out now. You can see I've got two pictures here, and we're going to play the video here in a second. But here's my refraction tank. So before we play the video, let me just show you what's going on. We've got a laser down here. That laser is being pushed upwards underneath the water. There's a bit of water going on here. So I can color this water in on my picture here before we play the video. And so if I color that in blue, I'm just going to make that a little bit bigger now. Okay. So if we color that in blue like so, we know that that is the water there. And the laser is coming up from the water. Now, of course, the same thing will happen as if we go the other way, but there's the water. Now, the thing is, at the moment, it's hitting the water boundary, the water-air boundary at 90 degrees. No refraction happens. Remember with the car analogy, if both tires are going into the mud at the same time, they both slow down at the same time, and therefore we don't bend. Whereas down the bottom here, you can see, and I'm just going to color this in again so we can see this a lot better. Okay, you can see that because we're now making the beam of light at an angle, it is bending. Okay, and that bending is called refraction. Okay, so if I was to draw on these diagrams, I'm going to draw on these diagrams after the video, but let's play the video. And so as you can see there, as we're moving the laser at different angles, it's causing a different amount of bending, but at all angles from this video here, it's bending the light. The laser's bending as it's moving from a dense medium, the water, to a less dense medium, the air. Okay, and as we learn more about this, you can predict which way it's moving. But at the moment, the fundamental concept is it's bending as it goes into a different medium. So now back to our diagrams here. I could label these if I wanted to, right? We could change color and we can go, okay, well, this is the normal. Okay, and so if that is the normal there, I'm just going to put an N for normal. Then if I was asked to label the angle of incidence, which is over here, so that's going to be the angle of incidence just there. Okay, so we go theta and I. And we could go, let's do red, and we can name this ray here, right? That is the refracted ray, right? So that's the refracted ray. We have a ray that's coming into the boundary, right? Even though it's starting from underneath the water, it's coming into the boundary, so that's called the incident ray. And then if we wanted to, we could talk about that angle there, and of course that is called the angle of, the angle of incidence is there, the angle of refraction is the other side. See? Okay, let's fix that up. We noticed it, so let's fix it. So that's the angle of refraction. That makes sense now. Right, we've got the incident ray coming in, so therefore that's the angle of incidence. We've got the refracted ray coming out, so that's the angle of refraction. We've fixed up the momentary error, not a problem, that's called learning. So there we are, that's it. That's a quick video explaining the refraction tank, refining and reinforcing the concepts that we know about refraction. See you in the next video. So just like the quote here that you can see on your screen, which says success is the sum of small efforts, we've got to make sure that we repeat ourselves and constantly challenge our learning. So all the stuff that you've just learned, can you recite some of the key ideas from this video? Can you describe the key ideas from this video? Can you draw diagrams or something to explain what you've just learned to somebody else? So in order to do that, we need to check what you have down in your notes. So do you have detailed notes with diagrams? We're not looking at just writing 1 or 2 sentences. We're making sure we create new pathways to remember your information. So detailed notes, using color to highlight key definitions and terms. You're writing down questions, of course, to yourself or to your teachers. If you come across something that you're not too sure of, make sure you find out what that means. You've got to make your learning meaningful, right? Just like we say in all the study videos. If it doesn't make meaning, you're just repeating words that don't really have much sense to your brain. It's got to make sense. And then, of course, do you have a plan to frequently revise the material? How often are you going to look at this? Have you watched the video that talks about the frequency of study and the memory curve? So think about all of those things after every single video, because we want to make the information go into your brain and make sense, so then you can retrieve it anytime, any day. Okay, I'll see you in the next video.